welcome guys, and thank you for coming to the. I'm just curious if some more people are coming to the presentation because I have to approve them. Like, where do I see it?
Oh, because you are a host right now.
Yeah, so I'm concerned about maybe people. I leave this.
If I become host,
How do I put you on host so I don't have to?
if you click on my avatar, the three dots, you can make me a host, and I think you won't lose the presentation.
Okay. You the host now? Can you people still see me? The presentation?
Yeah, I still see the screen.
Yeah, all right. So welcome guys. I prepared this lightning talk, really like quick stuff for here at White Prompt. I'm really covering just the basics of what's Docker, what can it do for you, like the biggest wins that I've seen in my opinion and that I've seen towards the community, like what people enjoy the most, where people take more advantage on Docker. And I mean, as the title of the talk says, I'm looking to revolutionize your development cycle. So let's talk by, that's my guide of the whole talk. So or the whole topics that I'm stepping here, but there are mostly demos, right? So I'm just talking about like very simple concepts on the first, and then I'm talking about demos. All right, so lightning talks. So what are Docker biggest wins? As far as I can see on the community and I mean on books, courses, people highlight those three things the most. So Docker is about saving time and money. And what do I mean by it? About saving time is Docker really bootstraps a lot of the infrastructure for you. In that sense, you wouldn't have to, let's say you just start, let's say you know Docker, all right? You study it for a while and then you're familiar. And then you start in a new project with the client and this client uses Docker. So you wouldn't have to spend like an afternoon, sometimes more than a day, setting up your local environment. This is really like time saving for developing, for the developer, but it's also time saving when you set up the infrastructure on the cloud or in a production environment, because it does the same thing for you. It has the whole portability and, you know, I mean, you guys are a bit familiar, you know what I'm talking about. So when you have an application, you don't have to set up the Postgres database and then set up the app, sometimes configure local environments, like environment variables, and sometimes configure new files, logs, etc. And even specific libs that only touches your own operational system. Like for example, if you're using Linux, you have to install something. If you use Mac, you have to install another thing. Docker really saves this time for you. So you only would need to have like a Docker configuration in your project, and then everything else is resolved by Docker. And by the way, the environment will be the same. So about money, one really important thing that I noticed in Docker is that it takes much less space for you to host an application, let's say in Docker, than in a VM. So you're seeing some examples here throughout the demos. And like really the biggest container that we will create will be something like 100 megabytes, all right? So that's not much. If you're familiar with other technologies which bootstrapped applications using virtual machines, like Vagrant, let's say, you'd have like a much bigger space cost and of course memory cost for your application to run. That represents a huge save on money, and that's really special if you have like big applications, big deployments, and on production, you know, because as you know, cloud space and cloud memory costs money. So About the portability, I actually figured right now talking to you guys that I should put it first. The portability is all about like having your infrastructure bootstrapped in a file. So as you guys you see, this is called like the Dockerfile, and like it's really like a matter of learning how to do it first, and then the second one you do like really quick. And the documentation of Docker is actually one of the best documentations that I've seen so far. All right. I also include like a point here, which I enjoy myself personally, and it's about testing up tools. So let's say you're like let's say Node.js enthusiast, then you want to test like the latest version of Node, but then you don't want like to have it installed in your environment because sometimes you have to tweak something and you don't want to mess up your local environment. Or maybe you want to test the latest version of Python, and I mean you don't want to have to download the whole CPython repository and then compile it. So Docker really resolves this for you. You can like in a matter of let's say 20 seconds start working with like the newest Python release real quick. So that are the 3 points that I think it worth more to highlight. And yeah, so about the Docker architecture, that's something that I emphasize before to you guys, right? So that's a huge save of money. You have Docker like already working on top of your host operating system. So let's say you buy machines on the cloud and they're hosting Ubuntu, you know? So Docker comes right on top of it. You don't have to, for example, if you're hosting a virtual machine to streamline your application, you'd have to have an hypervisor, and then on those virtual machines, you'd have like another guest operating system and your application in the end. So as you guys can see, that's like the best of both worlds, you know, because you have the portability of having like a host environment for your application, which is the same always, and it's lightweight. It doesn't occupy much memory and disk space, and well, we see what can it do for us. So here's the basic architecture for Docker, and what it does for us. So Docker is a very, I mean, basic tool to manage. It is just like a Docker daemon, which is sitting on top of the host operational system. And then you have a REST API, right? That's really important. You have a REST API in which you communicate with the Docker by using the Docker client. And through this REST API, you can manage everything that I'm showing here on the screen, right? So you can manage your container. I haven't talked about these concepts yet, but you can manage your container. You can manage your network, your images, and your data volumes as well. So throughout the demo, you learn like step by step, each one of those concepts, and I'll try to touch like really quickly, like what's the basic step for like building an application and Dockerizing it, and then we'll run over to learn which each of those concepts. All right. So before saying those things, something that I found out that it really surprised me is that Docker is only 7 years old. It was like conceived, I think, 2013 March, and like the guys received the funding, and it grew up really quickly, and it's basically written in Golang. So it's the kind of application which is really efficient, and it received a lot of like endorsing right from scratch, right? Because it had VC from the Y Combinator. So so yeah, that's the whole history of Docker that I would like to point out, and let's concern more about the concepts, right? So For example here, let's say you are the client, and then you want to run your application, let's say. What do you do is that you use commands like docker build, pull, and run. And then, for example, you have your application, then you can use docker build in order to build an image. And you see how does it work right in a moment. When you have like external images, so for example, you work in a corporation and then you have non developers. So obviously, you don't want to build the image every time you pull new code, all right? So Docker can do this for you, and then you can pull the new images right to your machine and start to run the newest application that you have on the corporation. And Docker run, of course, is to run the containers. So one way that I like thinking, let's see, I think I missed this slide. No, it's right here. So one way that I like thinking is that Docker is basically files, all right, in which you build, and then you create an image, and then you run this image to attain a container. So what's a container? A container is quite complex, but at the same time quite simple. You can think of it as a process. It is being hosted in your Docker daemon, and it runs locally. That's basically it. You can go throughout like really complex concepts like J groups and, but I don't want to enter that field and get more like a practical point of view of what Docker can do for you. So the hello world from Docker, I mean, like we pointed out that we'll show you how to install Docker, but that's really like, shouldn't take like more than 15 minutes, all right? So you should be able to do this on your own. It's quite quick. And once you do it, you can have something like, you can do this command, all right? So you can go ahead and do like Docker and then run hello world. This is the first command ever that the documentation points out for you. And it shows like the whole process that Docker does in order to show this image for you. So first the client contact the daemon, which is kind of the Docker. You can think of it as the engine, the server, the part of Docker which hosts the containers. So the client, which is the CLI here that we're using, kind of talks to the daemon, and then it pulls the image called hello world from Docker Hub. That's a really important entity when you're using Docker, by the way. So every time you want to find a Docker image, you can go to Docker Hub and see if people have this build up for you, because normally they do. So Docker is a huge community. I've seen in the past few days that it has more than 50 million developers right now. So it's a really huge community which grew in the past 7 years. And it has basically everything there. If you want like an Ubuntu image, you have it. And we, of course, can build our own image, as we will learn here. And all right, next, it creates a container, right, from that image, which runs the executable and produces the output you're currently reading. So it pulled this image called reload world. It created a container to run this image. And then the Docker daemon streamed that output to the Docker client, which sent you to the terminal. So by only doing this step, it is like producing output, but you cannot read on your TTY, on your terminal. So this first step is really important. There's also a command that we learn here. Yeah, so it says something like, if you're ambitious, try to run a container called containing boot or something like that. So let's try that and see what it does for us. By the way, guys, if you guys want to comment anything, like, please let me know any questions following up. So let me know, please. I'll try to answer. So unfortunately, I didn't have like a latest Ubuntu image, but it just pulled from Docker Hub. Amazing, right? It's quite fast. So let's maybe try to go home. By the way, what we did here, we called Docker and we called IT. So if you guys want to know what IT means, you can use the help, kind of the help parameter in the run. Sorry, you have to do this here. Right, so I stands for interactive, which means that the std is attached, all right? And the T stands for TTY. So that's basically the fourth step that we had here. So we need to stream the output of the client to our terminal. So that's it. So if I try to run again, the same command, we already have this Ubuntu image, all right? So that will run instantly. So let's try, for example, go home and then create a file, let's say my file. All right, if I try, let's say, to edit it, then I don't have Vim yet. So what can I do is I can install Vim. And of course, I mean, I don't have the package updated yet, so that's it. Then wait for a few minutes, I mean moments, not minutes, and install Vim. Then it's really quick. It installs like stuff like blazing fast. And it's just like if you had an Ubuntu environment inside your Ubuntu environment, right? So let's try to edit this file. Hello, from Docker. Then we can, right? So one thing that I want you guys to notice is that we will use the command run here. So once I go out from this container, there will be no container running. But if I go outside the container in a new terminal, and then I put like Docker container ls, you can see that things are really similar to Ubuntu, right? Straight, right? So if I type Docker container ls, you can see like there is a container running here. The image which it was built, it is called Ubuntu, which is expected, and you have like the created and the status. Something that will like put some knowledge here is that name here, because once you want to stop containers, you have to use the name, but that's for another demo, right? So that was the really basic demo for using Docker to build, to pull and run an image, and we executed bash with it. Now, what I would like to point to you guys is the size of the image. So if you guys can see here, when you type Docker image ls, you can see all the images that are on the system, right? And as you guys can see, Ubuntu image has a size of 73 megabytes. I mean, nowadays in 2020, it's not that much, but it used to be like a lot, especially if you have a slow internet or if you are in a place which, I mean, don't have fast speed internet. So what I do recommend, and what I'm going to use on most of this demo, is Alpine. So Alpine is like a Unix distribution, and it's really small. As you guys can see, it has like only 5.57 megabytes, and it's basically the same thing. If you want to run the Alpine image, instead of Ubuntu, you put Alpine. And then what Docker will do is it will reach Docker Hub, see if it has the latest version of the image. If not, it will pull. Then you have like a shell here, as you guys can see. You have the shell, and you can do basically the same thing. The only difference is that now you're not in a, I mean, it says Ubuntu here, but it's really Alpine. It's the Ubuntu kernel, but the point here is that you don't have like apt anymore. You have something called APK, right? So for example, if you want to add Vim, you have to put APK add Vim, and then file. Sorry. So it's basically the same thing, but it's another operational system. You have to learn maybe one stuff or two. But it's really stable right now, and the Docker team is really putting a lot of effort to make Docker images with Alpine, because they are really portable and small size. So you guys have some questions so far? Any question?
I have a question,
Sure.
Rafael, regarding you a moment ago showed that when you listed from the host machine the containers, Docker created one ad hoc to run the command that you specified. When you did Docker run it Ubuntu bash, it created a Docker container. Once you exit the session from that container, it kills the running container, right? So
it does. So it actually doesn't. The term that we use is it stops the container. So why? Because you can see here dockerls that the container isn't running. But if you put dockerls -a, you can see stopped containers here. So for example, if you want to like restart Alpine, then you can like, I mean, that's the point that I want to get. You have to use its name. So you have to use something like Docker container start. Sorry. Then you put this. Thank you. The container. Now start.
I think you're putting the Docker there again.
Yeah. I have to put like this here. Yeah. So like this, you start the container, but you're not running anything. So for example, if you want to run shell command, put like docker container exec and then -it, sorry. And that's it. Yeah.
Oh.
So the point here is like so far, what we learned is that when you use the run command, the docker container goes up, but only until you stop it, you know. Once you put like end of file, like Ctrl-D, then it stops running completely. But I will show you guys like how to do it better. And I mean, that was just like the first scratch, right? I'll show you like how to Dockerize an application, etc. So something that I'd like to point out is Docker images. Docker images, they are really like, they have like protected layers, which are kind of immutable. And then they have like the RW layers, which are like what you could access and change. And what I mean by that, I mean, I would have to explain like showing a Dockerized application. So we could, I mean, I could show you guys what this means. So I prepared one here. And so the first one was about that, it was called creating Dockerfile. And yeah, so how did I create this Dockerfile? First of all, you go to Docker Hub, right? Every time you want to create like a new Dockerfile, you go to Docker Hub if you have something like ready for you. And our goal here is to create a simple Flash app. I already have the app working. What I would like to do is to put the whole environment on a Dockerfile. So what do I do first? I, of course, would need like Python and pip environment. So I go for Docker Hub and try and type Python. So let's see which versions of Python does it have. So it has many Python versions. And what I chose here was to use Python, and then you put the tag, you know. The name of the image itself is already Python. Then you put like from Python, and then column, and you put your tag. So the tag that I choose here was 3.7, you know, because I mean, that's my favorite version of Python, and Alpine because of that factor of size that I've shown you guys. So the next step is that you have to create a folder for your application to stand. And I mean, the real default right now in the community is to create like a folder called app. And then you create like the work D and point this to the app. This is really like basic configuration stuff, and that's not a layer. I'll explain to you guys, like when I build this image, what does it mean? Then you copy the requirements, which is basically your dependencies. If you're like, for example, in a Node.js environment, you would say like, you copy the package JSON, right? And then you do the dependency installation. So a real important thing here, and there's really a caveat that bites me sometimes when I forget, is that before copying the whole folder, right? That's what it is doing here. It's doing recursively by default. It's recursive. But the real caveat here is that you have to install your dependencies first, and then you copy your application. And why? Is because the way that Docker works is that it creates several layers in your image, and each layer can be reloaded, all right? So if you do the package installation first, you wouldn't have to reinstall everything every time that you refresh your application with new code, all right? So that's something really important to not forget. Like always install the requirements first, and then copy your project to inside the container. Something that I'd like to highlight here is that this app is inside the container, right? This is a folder inside the container. Then you're setting the work queue to a folder inside the container. Then you're copying everything from local to the container. And then I'm running Flask's command, which runs the application by itself, right? So if you know Flask, you know that that's not the only thing that you have to do. You have to set some environment variables, etc. And you see how to do this here. So let me check my, my cheat sheet. And so the first thing that you should do is to build the image, right? And I call it like a really, how does it call? Like a really brief name, just LT, Lightning Talks. So you can like start to going faster here. So something I have to do first is that since I already have this image, I have to delete it. So image rm, and then I have to delete the LT, right? All right, so I deleted the LT image, which is called untag. So I untag the LT image. You guys can see it's not here anymore. So I'm going to build it. All right, it built the whole thing like real quick. It actually used a cache here. I'm wondering how do I solve this. Should I do like a system prune, maybe? Yeah, let's try it. So that's something that can maybe like make the presentation go wrong, all right? Because docking system prune, you delete like every single image right here. So it will delete everything from my containers. So I can show you guys how the process of building and doing those commands really works. So as you guys can see, I freed like 300 megabytes of memory. So let's see. So first of all, build the image. One thing that I would like to highlight here is that for each step on the Dockerfile here, it is creating a step. And the important thing now is that we have an image called LT, right? In order to build this LT image, it pulled like an image called Python from Docker Hub and used like Python 3.7 Alpine. So let's inspect this image and see what it's about. So that was the thing that I was highlighting to you guys, is that every one of those commands is except for work gear, it will create like a new layer. So let's say we build this image again. You see that everything is already cached, you know, like using cache, using cache, using cache. But let's say we like, we put like a new dependency, let's say, so let's put like gRPC. So when we do this and build the image again, it sees that, yeah, because it's not a package. So it sees that you actually modify, I mean, I'll leave it as it is. So you actually modify I'm having some problem with people, right, by the way. So that's all about this package, not about the Docker per se. The thing that I would like to highlight here is that it sees that you have some modification on one of your steps, one of your layers of your Docker image, and then it tried to rebuild like an image again from scratch, right? Let's see if I don't know. Yeah, it's not valid. All right, I give up. So the point here is that everything that you change here, let's say, put like hello or.
Sorry, Rafael, you need to use double equal there, so to change the version of Flask.
All right, but yeah, thank you. But the point here that I wanted to highlight was like every time that you change something, and like Docker detects that you change one of those layers, maybe you change the requirements or you change some file, then it will rebuild the image again, but it will use like previous layers without touching it, you know. So a Docker image is actually, a Docker image is actually formed of several layers which can be reused, and those layers here are like immutable, you know, so they have a hash, and either they are rebuilt or they're like they stay as the same, you know, as cached. So that's important Docker concept, and this actually makes your application more secure. So next point here is like, how do you publish this image? All right. So if you go to Docker Hub, I mean, I think I don't have any image currently. So yeah, no image. But let's say, how do you put this image on the web for people, say on your team, or like your friends, school teacher? How do you share this image with them? First thing you have to do is Docker login, but I'm already logged in, so it's not asking me anything. By the way, if you do this in production, like be careful and read the documentation through, because like you storing your password here, you know, so maybe you want to do it another way. So next step, then you pick an image that you have, for example, Docker image. Then you have this image called LT, and you tag it. So I'm going to tag it like with my user ID, and then I put the image, and then I put like a special tag called latest. All right, I just tag the image, and next thing you do is to push it. All right. So while I speak, it is pushing the image.
It's a pretty similar mindset as GitHub or other version control systems.
Yeah. They really took the Git and the Unix mindset and they put here on Docker. So
nice.
Hopefully we'll see like the new repository here. So yeah, you can see like Rafael RDS LT. And the thing is, like, I use the tag latest, but we could really like use another tag. Let's say choose 0, and then we could push. As you guys can see, a lot of layers already existed on remote, so it didn't push those layers. You know, it was just like just published the different tag that should appear here in some moments or something like that.
The idea is that latest will also point to the latest version or the stable version, and but then you can refer all their tags by its version, right?
Yeah, so you can create like your own tag, and like, for example, Porcupine, those kind of things, you know, and then you can create those and, you know, take advantage of layers which already exist and really have like a different distribution and, you know, tag things differently. And I mean, let's say you have an image that you just shared with me, and I want to maybe, let's try to delete this one. I'm not sure how to delete it by heart, but let's see, doc image, rm, say Porcupine. Yeah, so I untagged LT Porcupine. So how do I do to get this image from remote with this tag? Well, it's quite simple. You just, instead of rm, you just do like poll, and hopefully it will work. Yeah, it did. So you can see here that I deleted this image called Porcupine and untagged it, and then I pulled from remote. You know what I'm saying? So it's really quick for you to create a repository and push your images already built and share with your friends, etc. You know, and that's something that I wanted to show you guys. So for example, if you want to know what's inside the Docker image, you can just come here, let's say like the newest one from Python, and you can click on it, and you can see their Dockerfile, you know? How did they build this Docker image? Of course, there are like official images, so they are really safe, but you can see everything. It's everything like open source, you know? So you can see the configs, and you see if you think this is a good image for you. And this CMD here, just like what we have here, this CMD here is the command that you will get when you finish like running this image. So, I mean, let's continue on the talk, because I think I want to show you guys lots more stuff and have this much time. So for simplifying this talk, I'm going actually to simplify those tags, you know, and instead of like using this complex tag called Rafael RDS LT, I'll just call like LT, right? So what I did here is I tagged this image with a new tag, just LT. Then I deleted the previous tag, which was like binding to my username at Dockerfile. So let's continue. What I'm doing here, like I'm really putting like just some commands and step by step, right? So if I want to run this Dockerfile, what I have to do is, I think this is better, right? No, it isn't. So what I have to do is I just do something like that. Docker container, and then we put like the commands which are the interactive and TTY, all right? And then we bind ports. By the way, this is something that's really tricky for some people sometimes, that like binding ports and like really exposing ports to from the Docker container. And the thing is, there's a command called expose that you put in the Dockerfile, but it's kind of deceiving, because that's not really like a porting forwarding, not really exposing any port. you just like documenting the port for not developer. That's something like that. So what I usually do when I'm not using Compose, which I'll get in a few moments, is just that I put the host port here, then I put the the Docker port here, all right? So on the end of the Dockerfile, I expose it like, all right, I'm serving this application port 5000. The same way I'm putting the port 5000 in the host. Then I put like the E parameter, which is for environment variable, you know. So if you want to expose any system variable, environment variable, you just set it here. Really easy, like a Unix expose, and then you pass your image, all right? So this LT here throughout the whole demo will be our image. So you just do it, and hopefully it works. So yeah, hello world. The application itself is just doing this, you know, right now, but we'll get into a more like complex application with like persistence, a small database, but happily we are running like a application, maybe some stateful application with business logics could be run by this simple Dockerfile, you know, so that's quite useful already. And the next step is like, how do we stop this? I mean, you already know that if you want to run it, you do it like that, right? But I want to show you like a different command. If you want to run, and if you want to disown the container, so you don't have like the logs and the application bind to your terminal. You just do -d. By the way, if you guys want to check it out, it's really quite simple. You just do like .container, then you type help. Then you have like basically everything that you can do in the command Docker container. And what I really advise to you guys is to always use those management commands. So if you do like Docker help, always try to use those management commands, because in some time these commands here will be deprecated. And those commands here, the management commands, are actually the ones that are advised by the community, and the ones that will stay for like the long run. So always try to, I mean, the whole talk will be built towards this. So instead of doing something like Docker PS, we do like Docker container ls, all right? Because that's the new and more clear command, which is called the management command. It's just like a high note. So you guys can see that I use the -d parameter here, and that disowned the container. That was your question, Fabrizio, right? So right now we have the container running, and like to stop it, you have to do it like you know, by hand. So what do we do right now? This container is running, then we want to stop it. You just do a Docker container stop, then you have to put like this weird name. That's usually the distribution of Alpine in which it's running. So you stop it, and I mean, this takes a while, you know, to stop a Docker container. Sometimes more than to get one up. Something that I like to introduce right now is that if you do the same stuff, it will get like really tedious, you know, to keep doing this, and I mean, just repeating. It's a lot of pain. So something that we can do is creating like a name on the container, and that will make like our life much easier to remember what's the name of the container, how to stop it, how to run it. So when you use this name parameter, it will change the container name. And I mean, I advise you to always use this RM, because once you stop the container, it will also like remove it. Otherwise, you would have like it's not really a bug, it's just like a pain. You'd have like a pain getting this up again, you know? So always use it with the RM parameter. So once you stop the container, it will like also delete it from like not to be dangling, right? So you do it like that, and our container will be running. You can check here. It has the name light-talks, right? If you want to run it, dezoning it, you just pass like the -d, and then you can see the same stuff. And then you can stop it just by typing its name right now, right? So same process again. I think you guys are familiar with manipulating the containers already, so that's something. Let's get this up again. And right now, something that is always useful is once you have those containers running, like how do you check the logs? I mean, it's really similar to Unix. So just do like Docker logs, and then you pass here. But then like you're doing some requests, you know, and you want to see those requests. You don't want to like have to type again and again Docker logs, and logs can be pretty huge. So you don't want to have all the logs here. So what you do is -f, and then you bind like the logs to your TTY. It's pretty similar to Unix, all right? So you can see here some more requests, you know, create more requests as we speak. All right. So next step is to see the status. So we have this command running here. So what can we see from its stats? It's just like you're doing like a htop. Then you can see like how much memory it's using, how much processor, the name of the container. And if you have like a lot of infrastructure using containers, that's really useful, especially for a sysadmin, right? And by the way, you don't quit it with Q, it's Control C. It's quite tricky to get out. So Docker run, I already explained the two like most tricky parameters with like -i and -t. And now what I'd like to do is try to update the code while you develop. So let's say you're developing a feature to this little Flask application. How do we do it? So Flask has something really funny. And I mean, that's one of the reasons to choose Flask. It's because it has like a way of doing things that sometimes you don't agree, but yeah, it is what it is. And you have to set this debug environment variable here. And I mean, it's the same command, it's just that I put the debug environment variable so it reloads the code. As we update. And let's see, yeah, so it says that we have like lightning talks running. So what do? We stop the container. And then yeah, it can take a while to stop the container. That's quite sad. So we're doing the application again. We're running the application, and let's see. Hello world, and let's say we put like hello prompt, right? It doesn't update. So the problem here is that our code is just like mounted once into the container, and it's not updated after. And that's something that Docker doesn't do by default, because let's say you're deploying Docker application, then it doesn't make any sense like to have like a live reload. In order to do this, you would have to mount the source code into a running container. And I mean, it's just like a simple command. You put like a volume, you know, And then by default, the community uses something called app. And PWD is basically like the repository, the path in which you are executing this command. So by just including this, you would already have like live reload, right? Let me try showing, then hopefully it works. Hello white prompt. Then let's update like in real time, no? 1, 2, 3, 4, 5. And yeah. So now the code is like reloading every time you touch the file. So let's say you import datetime. Datetime. Right? So it detects the change and reloads. And by the way, it only loads that layer, you know, that we talked about. So yeah, I think that concludes the real first part of this here. And the second part, I'll try to go quicker, you know, but I mean, you guys let me know if you have any questions right now, because I think I'm like really trying to explain the concepts deep, but you guys have any questions so far?
It's quite clear for me.
Okay. So something that you can see also, let's say you have this here. Last, and then let's try to inspect this container like docs. And you guys can see, for example, details about the container. Like, for example, like environment variables that we pass, the image, the network. That's something that we're going to address right now. And yeah, I mean, Docker is a really transparent and clear with the developer, the sysadmin. So it's really a nice tool because you can see a lot of stuff of what's happening. That's very little obfuscation on the whole environment, right? So that's something that I really enjoy with Docker as well. So next part, all right, close all, and let's try using networks. So the application that I showed you guys before was really basic, right? So it's really like just like a really simple Flask server, didn't have much anything. And let's try to put some complexity here. I mean, it's not like the most complex application ever, but let's try just to put a small layer of complexity. And that would be like a Redis server, all right? So for this, I've chosen like to have Redis 6, okay? And it's quite simple. What you have to do is, as I told you guys, like you want to have Redis, then all right, what's the Redis image and tag that we're going to use? Go Docker Hub, you look for Redis, and you say, all right, Redis here, what's the latest version? Right, 6. Then what do is you just pull this image with Redis, with the name of, which is the name of the repository. Then you put the tag, right? So I put 6 and then I put Alpine, you know, because I don't want to spend much time on the demo pulling images. So, all right. So let's just try pulling. Yeah, as you guys can see, we have like a Redis server image and it's not much things, just 32 megabytes. Can you imagine like how much time you're saving instead of like, all right, let's go to Redis website and then let's try to understand like what, I mean, you still have to understand the variables and you still have to understand Redis, but you don't have to set up like a whole local environment just to receive Redis. And as Redis will communicate with Docker through the network, something that I'd like to point right now is what's the network concept in Docker. So it usually have by default these 3 networks already. And by default, when you start an application to use the bridge, okay? So the bridge has some implications on it. What's this? All right, has some implications on it. It has like an IP address, doesn't have an ingress filter, doesn't use IPv6, etc. Let's try using this image and see what happens, all right? So same command that we learned from before. Then I'm condensing this parameter here. Let me just condensing this parameter here. If IT end up also putting this on, all right, so it is from the background. I'm having this host machine port the same as the Docker machine port, putting the name of the container with Redis, and using the Redis image, Redis and tag 6 Alpine, all right? So for some reason it's, all right, so container ls, and yeah, so it is working. And now let's try to build this current Dockerfile. And I'm putting this, a different name using LT2, just so it doesn't get any ambiguous, all right? So let's try to build this app here from this folder. It has different dependencies. For example, it has Flask Redis, and the code, of course, is different. So we want a different image, all right? So once we do this, try to run the application again, all right? So by running it, you see like, wow, it doesn't work. So I'll try to go a bit deeper into the network concepts of Docker, so you guys can maybe try to have an understanding of what's not working and what's the kind of correct and easier way to doing it. So for example, if you see like the containers which are up right now, you can do like doc container or less, and you can do like basically anything inside those containers. So for example, exec -it, and then you can put like, for example, LT2, which is the name of this first container, which contains the application, and you can have like bash. Yeah, it failed because it's Alpine, so SH, all right? So what can we do? Let's try to explore a little bit more about the networks. So for example, if you try to ping like this, it doesn't find Redis by the container name. What you have to do instead is, for example, to see the network config of the LT2, which is this container. Then you can check, for example, for Redis as well. And you can see like they have different IP addresses, right? So let's try, for example, executing from this container called LT2. Let's execute ping. Let's ping this IP address on the Redis container and see what happens. All right, so it does work. For me, that's really beautiful to see two containers like talking with each other inside the network. And something that you guys can notice right now is that the bridge network now contains two containers, right? The two containers are being hosted on this network, and they talk with themselves by using IP addresses, like private IP address, of course. And that's good, but that's not ideal, you know. What I really would like is to have something like, let me just show you guys, like it has like a discovery here on the etc host, and it has like the kind of the hash address of the other container on its etc host, because it's on the same Docker network. But the ideal thing would be to have like automatic like dynamic DNS discovery. And the way to do this is happily quite simple. So what we can do here is Docker network ls, then we create a new one, and then you just have to do like driver, and it to be like a bridge network, and we call it like my network. All right, that's it. Then you guys can see to have like a new network right now. And just by having this new network, now we can pass like a net command, and that's it. Those new containers, container ls. So I actually want to stop 2 containers at once. How do I do it? Just put like the 2 names here, LT2 followed by Redis, right? And we stop them right away. So I like to have these containers up, but with the network that I just created called my network. All right, so let's do it. No problem. And same thing. All right. So the magic thing here is that now that we have 2 containers on the same.
Sorry.
So yeah, go ahead.
Sorry, Rafa, can you show you the Docker network ls? No, sorry, the ls. Okay.
Yeah, so for example, you can inspect my network, and you guys can see
This
that,
one.
yeah, you guys can see these 2 containers that I just had up running inside my network just because of this. I mean, I created the network at first by running this command here, right? Create driver reach my network. And then I put like a parameter called net, my network, and then LT2. All right, so what's the biggest advantage that I can see here? For me, at least, is that you can do something like that now. Then it will work. That for me is like the most amazing thing ever, because you've seen that those 2 containers are on the same network, and then they can discover each other by its container names, you know. That's really like mind blower.
Yeah, pretty. I mean, this opens a lot of possibilities. In the past, I built containers with all the stack inside the image to avoid this configuration. This makes it much easier because you have a lot of small containers and allow them to speak to each other.
Yeah, you just have to define your own network, and then it will have like automatic DNS discovery as default. You know, it's quite easy.
Can you run the container with several networks, as you say, /net, and put more than one network there? Is that possible?
I'm not sure, but we can check it out. But I'm not sure yet. I can see that this network stuff. I mean, I just scratched like the real basic of it. It's really powerful, and you can do a lot of stuff with it. So I know that you can do much more than just this, but I don't know if you can run in like different networks, for example. But I understand like what you're saying. Maybe one machine can access one part of the network, and just this machine can access other part. That would be really awesome. Yeah, that's a really good question. So my application now works because, I mean, with automatic discovery, it can discover this URI, which points to Redis, right? Because Redis, and then it's pointing to URI, port, etc. What I'm doing here is real basic Redis, Redis stuff, just to see if it's working. Picking a counter and increasing it. So every time you access it, it's just counting +1. I mean, that's a feature just like having the number of visitors, right? And what we can do right now is, for example, you can do Docker exec, and then go inside your Redis container and call Redis CLI. So let's see. And yeah, so for example, you can have like keys, and you can see like your counter, right? And let's increment our counter by, say, 1,000,000. Yeah, and you guys can see here on the application that it is working over. We have some database quite quick, without much configuration, really portable. using Docker. Something else that I'm pointing here on this demo is that if we stop this application, you know, and let me stop it really quick. Then I will this up. All right. You guys can see that Redis lost its data persistence. And the reason for that is because persistence in Docker is not something that's default. Containers were actually made to disappear, you know, to be really like disposable. But you can achieve so, especially in databases. But I mean, Docker is really clear that you shouldn't abuse this, but basically for databases, what you can do is, for example, you can go here on, let's see, on Docker Hub, just a moment, Docker Hub, and you can see that they point to you for you to use the volume as data. So that's really like I mean, you can use anything you want, but that's the place inside the container which Redis will look for data automatically, all right? So and by having this knowledge, you just have to put something like -v for volume, all right? And you basically just specify for this Redis instance that it should look for data, right? That's basically it for this data. And there's yeah, it's already running. Yeah. So now you have the same application, but you already have like persistence. All right. If I destroy those containers here, then have them up again, like I still have the storage here because Docker is storing its data when it, I mean, Redis already has this built-in feature that when it stops, it kind of throw everything in a file. So you have this feature working only by using like this volume, and then you specify like the name of the volume and then the place. Yeah.
I have a question here regarding the volume. Is this path to /data pointing to /data in your host computer, right?
Yeah, but inside the container, as you guys can see here on the Docker Hub, you can see that data is stored in volume /data, you know? So it's being stored here. You see?
Okay.
So let me try to clarify this by, yeah. So, yeah, there was something that I didn't show how to do, but it's really like you have to create this volume called LT Redis, and then you can inspect it. And you can see here the multi-point, you see? So if you go here, for example, yeah, permission denied. Yeah. You might see your data here, I believe. Right?
Yeah.
So here,
nice.
Here it is. Just the counter. All right. Okay, so I think that concludes the network part. Then I'll show like some of you guys, I hope not be mad with me that I kind of show like all these comments and flags, but with Docker Compose, it's really quite quick to do everything. So for the road, I think you guys should learn like at least the management commands like docker help. Then you can see like here a lot of management commands. So for example, docker container ls and etc. All this stuff is really useful. You can also see like the space in which Docker is consuming in your system by using df. So it shows you like how many images do you have, how much space it is claiming on your machine. And also Docker info is something that's really transparent, and I mean, it shows you a lot of stuff regarding your Docker daemon, right? Also about cleaning up, sometimes you have like a machine production. It's good to have like this command at hand. So for example, you can do like Docker prune. I'm not doing it, by the way, because I still have to show you guys like Docker compose. And maybe have this command to clean up some stuff, not cleaning, by the way. It's useful on production machines in which you have to do some cleaning time by time. Like maybe every day or every 2 days, you run this in a cron. And if you want to stop all the containers, you can type something like that, all right? Quite simple. Any questions so far? Okay, then. So the third step, and I hope like I get you guys to like this, is that you don't really need to know all those commands, All that you need to know, actually, besides building your Dockerfile, is how to compose like a Docker compose. And the commands are really like, it's just like FSU putting a command that we are having on our like that, It's just like if you're having this command, but you're having this config in a file, or precisely in like a YAML file. So you basically configure services, like every container that's running, you can have here in the services. You can create a volume for your data persistence. You can have like the port being forward, specify the images. And for example, for the web app itself, you put it to build on the current environment, you know what I mean? So you're basically automating that whole thing that we've seen before, but in a YAML file. And to execute, it's quite simple, you guys will see. It's just like Docker compose pull or build. So in this case, I'm doing like build, right? So to do like everything that we encountered before, okay? And if you want your application app, is just Docker compose up. Hope it works. Okay. All right. So it is working. For this Dockerfile specifically, I chose something a little bit more complex, and that's the entry point. So the entry point is just like if you had like let's say a shell script or a bash script being called before running this command, all right? So what I did here is I exported environment variable called web message. And then I had this counter, like this template string, right? And I use it on the application. So I had this OS environment variable, and at the same time, which was, by the way, imported from the script. And at the same time, we are using like the Redis key counter in the same application. And we have all of this kind of bootstrapped and joined together by using Docker Compose. It's just like a matter of learning this and how this works, and that really have a lot of synergy with the previous commands that we've seen. So yeah, that's basically it. By the way, Docker Compose has 3 API versions, and I strongly advise to use the third one, but it's really up to you. Just be aware that you might find something that you don't understand completely, and sometimes it's because of the version, you know? So always keep in mind to look the version in which the compose file is being made. So yes, that's basically the same Dockerfile that we've seen before, with the only difference that we have the entry point. Just to push again this concept, the entry point is just like we're executing this bash script. You know, I'm giving executing permissions, and then I'm shoving it as the entry point. And what it does, it executes before the CMD. So you can actually take advantages of environment variables, anything you want from the script, basically, and have it on your application. That's really useful for production, actually. And also something that is kind of novel here is that the env file, instead of setting environment variables, I mean, Docker Compose supports this, that you have like the environment variable explicit here. But I think that's not the concern of Docker Compose file. So it also gives you like this opportunity of having a .env file, then you can configure environment variables separately. So I set some here and it works, you know. So yeah, about this Docker ignore file, that's also quite important for production. Not for the small application, of course, but sometimes you have like really huge applications that, you know, have a lot of generated files. So it's just like git ignore, but it's what you don't want to get into your containers. So if you have like generated files, which are just binaries, are not useful for executing code, you put it there, and that will reduce the size of the container overall, you know. That's really good for scaling. That's something that you should keep in mind if your containers are like 250 megabytes or something, and you have a problem with scaling, then that would be really good. Yeah, I think that's it. You guys have any questions?
One question regarding Compose, when you execute Docker Compose, can you spawn more than one image of one of the, more than one container of one particular image? Let's say you have like a worker or something like that, and you need more workers, you need to scale up that.
Yeah, absolutely. You mean like this here? You create like a worker? Yeah, you can.
Wonderful.
It's just like if you want to have a lot of workers, I believe you can do this as well. But I have to check it out. But most probably, yeah. Sometimes you can have like your application, then like, let's say, I don't know, like 10 workers. I've seen this working in production before through Docker Compose. So you can create another stuff here and, you know, and bootstrap this.
Really great.
Sometimes more than one, but yeah. But it's just a matter of like defining your services here and what do you want, you know? So for the next steps, like I really just scratched the surface of what Docker can do for you. For the next steps, what I advise you guys is like try to put an application using Docker in production. Try to see what's Docker Swarm, what's Kubernetes, maybe just like take it easy and see the basic concepts at first. And yeah, I think that's just like a little scratch on like the whole Docker environment. So if you guys want to chat and know anything more about Docker, or just curious, please let me know and we can discuss further in Slack. Most probably. Some nice stuff that Docker Compose offers you is that you can restart, for example, just one service. So you can say like, right, I want to restart Redis, and then it does it for you. Also, something that you should keep in mind is that some service, for example, web, it depends on Redis. So that's really important because if you put in web up, you want to have Redis up as well. otherwise it wouldn't work, you know. So really learn the syntax and what it can do for you is quite helpful. But yeah, I have a quiz for you guys. I hope you don't mind. Let's see. I've heard from Fabrizio that there will be a prize, right? Fabrizio?
Yeah.
Okay. Present. So let me see. Yeah, so you guys can try here. I wish there was no sound. You guys can join already.
Okay. What's the link? Did you send it?
Just go to Kahoot and then type this game pin.
Oh, okay. Kahoot.
It's just like an interactive game, so you guys can. And by the way, who is the faster and doesn't get anything wrong, like you get the most points. So yeah, we have one person already. So it's working.
180. There we go.
Something else? Someone else?
I'm ready to get the prize.
You ready? Someone else?
It's too much for me, but let's see what happens.
Someone else coming? No? Let's call. All right, so I'll start the, yeah, oh my God, that's already the limit. Jesus. It's because I'm using the free version, so.
No, don't upgrade. I can,
yeah.
I can give up my points if anyone wants to play in my place.
Yeah, let's start. Let's start. Who's coming?
I was trying to enter, but I reached the limit.
Yeah. Next time I'll do like a improved one.
Okay.
I've learned some tricks. So let's start. Basic edition. So that's just a warm-up question. So what do you guys think? Yeah. That's easy, right? Let's see another one. Yeah, I said that's in the presentation. So do you guys remember? Nice. Yeah, so Roger is leading on the top.
I want to win.
You guys remember this one? Whoa.
Oh.
All right. Nice, Roger. I think he's getting the prize. Yeah, so this question, I think I didn't make this clear. Docker actually has the container as a process, all right? So it's sharing much more stuff than if it is like on top of a hypervisor, you see? So that's the catch here. And yeah, it's not much safer. It's not much less safer, but it's not safer, you know, than using a virtual machine. Nice. Yeah, so you guys learned the concepts. Okay.
Yay!
In order to persist data, what should we use? I talked this on the right. Yeah. So just keep in mind to use named volumes when you need to persist data for database, Redis, etc. But try not to abuse it. And that's the easiest one, of course. No, are correct. So that's the important one. All right. Nice. Yeah, so that's it, you guys. I think Fabrizio won, right? Something like that.
The prize I was going to give was to help me to do some extra hours during the weekend. So I win the prize, so I will do it myself on my own. Sorry.
Okay. Hi, people. I'm Roger. Yes, I'm really, it's a type of game that I probably is quite not lucky at all.
Yeah, so
wonderful.
I'll leave this last minutes for like whatever you guys want to ask, and I hope you guys like to talk.
Just a comment. I haven't been using Docker lately because of the type of projects that I'm working currently, but I used it like in 2016. And it's impressive how much it has evolved. I was seeing your comments and how did you do the stuff, the start the containers, stop them. And the CLI is much more friendly right now. Just a comment. I'm really impressed.
Yeah, I do agree with you. They are really aggressive on the releases. So I think I don't remember a lot, but you can see this number increasing quite fast. So Docker, it always releases new stuff, and it really has like a good community which take care of the project, the code, and it's the kind of project that I can see still shining 10 years from now. So it's something that I think you continue producing good fruits for the developed environment.
Yeah, absolutely.
So yeah, you guys have any comments, questions?
Yeah, Rafael, I have two questions about the image or the base image that you were using. Is Alpine versus Debian or Ubuntu Small?
Yes.
I mainly use Node.js, and some projects I get using Node.js with a base image that is like 2 gigs, and then I try to switch to Alpine or small version. But which is the difference?
Yeah, the difference is that Alpine is quite smaller. So for example, let's go here and see, for example, Python, all right? So Python, Docker images, image ls. Then you can see, for example, this Python here is using Alpine, all right? Python Alpine, 3.7 megabytes. So let's pick let's say a default Python, right? RC Buster. Let's try to pull this image pull Python 3.9. It's just RC Buster. Can already pull this image. So to pull the image, and you see that the size is sometimes it's much bigger, sometimes it's slightly bigger. But we'll see here. It uses usually Ubuntu, when you have this kind of image. So you can see that it's already like downloading a lot of stuff, and as you can see, this image using RC Booster is almost 1 gigabyte. If you choose to use Alpine to run your container, you'd have like an image which is like 12 times smaller. that represents a lot when you're talking about the like cloud resources, you know. So sometimes you want to multiply this app in a machine, and you know you don't have much memory. So that's something that you should keep in mind. I'm fond of Alpine because of that, but some people use Ubuntu for different reasons, and when you need, just know that Alpine is a really slim version of Unix that you can use for your applications, right?
Okay. Did you find any downside of using Alpine?
Yeah, it had some bugs in the past. Right now, it's much more stable.
Okay.
But it had some bugs in the past, and depending on the application, you might find something that would, I don't know, some small bug that would block you, and it's a pain.
Yeah.
But most of the times with Python, it's working just fine. Maybe if another languages and different environments, it would be more difficult. But with Python, I'm having a good time with Alpine.
Okay, good. And then the second question was about the difference on the use on your regular workflow when you're working about stopping the containers versus putting down. So which is the difference? It's like you start your day, you put Docker Compose app -d, and then you start the container, and then when you're done, you stop, or you put it down.
Yeah, usually do like Docker Compose down. That would stop like everything that is running from this Docker Compose file. So
yeah.
When you're developing something, you of course would need like to know those other commands like Docker run, etc. Once you have this Docker Compose file, you can use commands like just like Docker Compose app. Then you can use like, by the way, -d to detach, then to be running in the background, all right? And yeah, when you don't want to consume your computer anymore and you want to play some games, you just put Docker Compose down to stop consuming memory and processing.
Yeah, sure. What's the difference between down and stop? It's like it removes all it stops the container and also remove it?
Yes, I think so. I'm not completely sure, but I think so.
Remove the volume, and you need to...
sorry, Docker stop. Yeah, so as you can see, it just stops the container. And now also removes the network,
okay.
which they're creating. That's it.
Okay.
Right. Does it answer?
Yeah, that's okay. Thanks.
So anyone has any more questions? Maybe? No. All right then.
Thanks a lot. Wonderful talk, Rafael.
All right, thank
very
you.
Good.
Thank you for the opportunity. Let's maybe, in the future have some other talk, maybe showing some stuff in a machine remotely, stuff like that.
It will be great to have a follow-up talk later on maybe more advanced topics, but you cover a lot of ground here.
Yeah,
really great.
I wanted to cover like the real surface that you can start to be curious about Docker and what it can do for you. Because when I first started to see Docker and see, all right, so how can I test this this Python image, and without having to install it on my environment? So just something like Docker container, and then you have to put like Python. Then that would install and run Python 3.9 on your machine locally, like just in a few seconds. That was really amazing for me. That is something that I think revolutionized the way that I was discovering new tools and programming. So that's something that I wanted to share with you guys, something really practical that you can take advantage right away,
Wonderful.
All right then. All right, guys. See you on the next one.
See you. Thanks a lot, Rafael.
You.
All right.
Okay.
Bye.
Thank you, Rafael.
Bye.
Bye.